Registers in digital electronics. Registers are fundamental components in digital electronics, particularly in computer systems and microprocessors. A register is essentially a small, high-speed storage location used to temporarily hold data and instructions. They are typically made up of flip-flops or latches, which are the basic building blocks used to store binary information, zeros and ones. Understanding registers. A register can store a group of bits such as 8, 16, 32, or 64 bits, depending on its design. The number of bits a register can hold is known as its bit width. For example, an 8-bit register can store an 8-bit binary number. Functionality of registers. Registers perform several critical functions in a computer's central processing unit, CPU. Data storage. Registers store data temporarily during processing. This data could be the result of a computation, data fetched from memory, or data waiting to be sent to an output device. Instruction storage. The CPU fetches instructions from memory and stores them in registers for execution. This allows the CPU to process instructions quickly without repeatedly accessing slower main memory. Address storage. Registers can hold memory addresses, which are pointers to locations in memory where data is stored. This is crucial for operations that involve accessing data from different memory locations. Types of registers. There are various types of registers, each serving a specific purpose. Data registers. These registers are used to store data that is being processed. For example, in arithmetic operations, the operands are stored in data registers. Address registers. These store memory addresses. For example, the program counter, PC, is an address register that holds the address of the next instruction to be executed. Status registers. These contain flags or bits that indicate the status of the processor or the outcome of various operations. For example, the 0 flag in a status register indicates whether the result of an operation is 0. Instruction registers. These hold the current instruction being executed by the CPU. Shift registers. These are used to shift data bits to the left or right. They are useful in operations like multiplication, division, and serial communication. Real-life example. Registers in a microprocessor. In a microprocessor like the Intel 8086, registers play a critical role in executing instructions. For example, the AX register in the 8086 microprocessor is a 16-bit data register used to store operands for arithmetic operations. When you perform an addition operation, the operands are loaded into the AX register, and the result is stored back into the same register. Register operations. Registers can perform various operations depending on the needs of the CPU. Load. Data is loaded into the register from memory or another register. Store. Data from the register is stored back into memory. Move. Data is moved from one register to another. Arithmetic logic operations. Registers often participate in operations like addition, subtraction, and, or, etc. Importance of registers. Registers are crucial because they enable the CPU to access data and instructions quickly. Unlike main memory, which is relatively slow, registers operate at the same speed as the CPU, ensuring that the processor doesn't have to wait for data. Real-life use case. Registers in everyday devices. Registers are not just theoretical concepts. They are found in everyday devices. For example, in a digital calculator, registers store the numbers you input, the results of calculations, and any intermediate data needed during the calculation process. This allows the calculator to perform operations rapidly and display the results almost instantaneously. Conclusion. Registers are essential elements of digital electronics, acting as the workhorse for temporary data storage within the CPU. Their speed and versatility make them indispensable for the fast processing capabilities of modern computers and digital devices. Understanding registers and their role in data processing provides a solid foundation for exploring more complex digital systems.